theory. I'm going to try to draw you the little Lewis structures over here while we work on them here. That way you can see them. I don't have to switch back and forth. We'll see how this works. So first off, let's look at the slides. So what I have open for this is lesson 23 slides. I have the periodic table opened. So let's go to that. And then, of course, I have the lesson opened. So whenever atoms undergo bonds, they're going to share electrons. Basically, we have the valence bond theory, which suggests how they do this. And what will happen is they need to overlap and basically share orbitals or have their orbitals overlap so they can share electrons. So what will happen is the first bond will always be a sigma bond, which is just an end-to-end overlap. And that's the strongest type of connection, of bond. And so the first bond will always be a sigma bond. So obviously if you have a single bond, your only bond is a sigma. But what will happen is then what you'll do is you have a side-by-side overlap for your double and your triple bonds, your second or third bond. And these are different. They're weaker connections, and they're called pi bonds. And so it's not as strong as a sigma bond, but it'll still work out. A double bond is stronger than a signal, just because even though sigma is stronger than pi, sigma bond is a single bond would be one sigma, whereas a double bond is one sigma and one pi, and then a triple is going to be one sigma and two pi's. So you don't necessarily double the strength and triple the strength just because that first connection is a sigma, which is the strongest, but your strength does go up a little bit as you go from double to triple bonds. Okay, so let's go to this. So what it says, we're going to need to draw the Lewis structure for molecules 1 and 2. So draw the Lewis structure of H2. So let's see if I can make it look decent here. So we have H. We have another H. And then they each have one electron. And so we can just connect that dot. So that's what the connection looks like. So how many sigma bonds do we have? Remember, the first bond is always a sigma bond. So we'll say we have one sigma. And then how many pi's do we have? Do we have any double or triple bonds? No, so you'd say 0 pi's. That's how we do this, okay? So I want you to try to do 3, 4, and then 5, 6, and then 7, 8. So try to do the rest of these sigma and pi bonds. So press pause. I want you to go through and try them, and then you can press play. Okay, so for 3 and 4, we're going to do N2. So let me see how I can delete this. Let's just do that. Okay, so for this one, for N2, so once again, you should have paused it, tried these, and you're watching me do it now after you've tried them. We'll have N, and it's going to have 1, 2, 3, 4, 5 valence electrons. And then N, and it's going to have 1, 2, 3, 4, 5 valence electrons. How do I know it has 5? Because I'm looking right here. N, it's in 15, therefore it has 5. And so how many sigma bonds do I expect to find? So this will be first a single, double, and triple bond right here. And then that's all we're going to have. So remember, the first bond is always a sigma, and then any additional bonds are pi's. So this is one sigma, and then how many pi's? This has 2 pi bonds. Remember, first bond is always going to be a sigma, and then the rest of them after that are pi's. All right, so then let's go and let's do H2O. So we have O, and it's going to have 1, 2, 3, 4, 5, 6. And then let's do H with 1, and then H with 1. Okay, now let's go ahead and connect. go ahead and connect right here. And that's it. Remember we looked right here. I saw that O has 6. H has 1. H is the exception. The O is okay with only 2. And then O wants to get to 8. So these are happy. So now how many sigmas do you see there? 1. And then this isn't going to count as a pi because it's a new bond. It's a new connection. So there's actually going to be 2 sigmas and then 0 pi's. That's what we get with H2O. All right, and then let's go and do the last one where we're doing sigmas and pi's. So C2H4. So we have C, and it comes with 1, 2, 3, 4 electrons. We have another C with 1, 2, 3, 4, and then we're going to have an H. And there's a total of 4 H's. So basically, we'll put 2 H's on each side. Sorry, that one's kind of sloppy. There we go. And so we can connect these H's to the C. We can connect these right there. We can connect right here. And then we can connect right here. So all the H's are happy, and now what we need to do is connect the carbon and connect the carbon. So now carbons have 8, and the H's all have 2. So how many total bonds do we have here? Well, we have 5 total bonds. Let's count how many sigmas. Remember, H to the C, this is the only connection there, so that's a sigma. Now it's a new connection, so sigma. New connection, so sigma, sigma, and sigma. So we should have 5 sigmas, and then how many pi's? Well, you'll notice the first bond, or the second bond is a pi, so there's just 1 pi. So that's how we do that. Okay, now I pick between option 1 and 2. Which one is going to have the stronger bond? So for this one, what we'll want to do, let's draw both O2 and we'll draw N2. I'm sure there's a much faster way to do this, but it works for now. So let's do O2. And so we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so what we'll do is if we connect them once, they now have 7. Connect them twice, they now have 8. But then when we get to N, it's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So with this, you connect them once, they both have 6. Connect them again, they both have 7. Connect them again, they both have 8. What's stronger, a double bond or a triple bond? Well, that would be a triple bond. So we get N2 as our winner here. Okay, so you're going to draw them and think about the things we know in order to figure them out. So try to do 10 and 11 now. Okay, so let's look at number 10. We're going to have C, 1, 2, 3, 4. C, 1, 2, 3, 4. We've actually already drawn this one. It's going to look like this. Bonded to an H. That might be sloppier than the last time I tried. Bonded to an H. And this one is bonded to an H. And then this one bonded to an H. Okay, so we have a double bond right there. That's the strongest bond in that. And let's check out CH4. Well, CH4 is just going to look like this. This is bonded to an H. Because C would start with 4 electrons, and then each H wants a single bond. So I know I'm kind of going fast on this. I'm not even drawing all the electrons originally because I'm hoping to get used to just knowing that C makes 4 bonds. So which one has a stronger bond? Well, it's going to be one with the double. So your answer is going to be C2H4. Okay. And then lastly, for this last one, we're going to need to think about some stuff from a previous lesson. So when we do NH3, we'll have N, and it's going to have 5. So we can go like this, H. We have H and H. So a triple bond, but they're all just single sigma bonds. And then with O, I think we've already drawn this one too. It's going to be O bonded to an H, and then bonded to an H. And 1, 2, 3, 4. And this would have been 5 and 6. So which one's going to have the stronger bonds? So they're both single. So they're both just sigma bonds. So remember with this, remember what you can go with on this is the further away they are on the periodic table, the stronger their bond is. So H over here to N, or H all the way over here to O. O is further away. So based on what we've learned so far, we'll use that rule, and we'll just say it looks like we can assume we think O would be the stronger bond because their polarity would be higher because they're further apart on the periodic table. Okay, now the last thing is a pretty simple concept. This one, what's going to happen whenever the orbitals are formed, you have the choice to form a bonding or an anti-bonding orbital. And an anti-bonding orbital is an orbital that's not favorable for bonding, but a bonding orbital is. So basically what happens if you have more bonding orbitals than anti-bonding orbitals, you can still form the molecule. So it's kind of like if you're in a car with a bunch of people and you're talking about where you're going to go to food, just because 1 or 2 people don't want to go somewhere doesn't mean it's not going to happen. Typically, if there's more people that want to go to a particular place than those that don't, then you end up going there. So that's how this is going to work. So I want you to use that. Try to do the last 2 problems, and then I'll go over it and we'll be done. All right, so number 12. A molecule has 4 antibonding orbitals. How many bonding orbitals have to be present in order for a bond to form? So if there are 4 people that don't want to do something, in order for the group to end up doing it, you must have at least 5. Okay? And then number 13, if you have 4, what is the highest number of antibonding that can be present without keeping the bond from forming? So remember, if you have 4 bonding, if you end up with 4 antibonding, that's enough to keep it from happening. So you can have no more than 3. So that's the end of this lesson. As always, email me if you have